Welcome to all Launchpad 2026 Kickstarting BE Beginning. Dear students and parents, we are pleased to inform you our SA Engineering College Autonomous Department of Civil Engineering organized Launchpad 2026. We are excited to invite school students to special section. Build topic build the future sustainable construction and AI shaping the future of civil engineering. Speaker Alagappan SP engineer with over 3 years experience in environment and product sustainability. He has a master's degree in environment and bachelor in civil engineering. In this role at CII Godrej Green Business Center, he is involved in the eco-labeling of product, net zero building benchmark and baseline studies for the life cycle impact of product and building. Thank you, sir. Sir, sections yours.
So good morning, everyone, and thank you, Vinod Kumar, sir. It's been thank you for, first of all, thank you for inviting me for this session along with the parents and the students who's going to enter into this new set of area. And to proceed with, let me introduce myself once again. So myself, Alagappan SP, I'm a proud alumni of SA Engineering College from the batch of 2016 to 2020. And then I completed my master's in environmental from College of Engineering, India, Chennai. Later on, I joined the CII, Confederation of Indian Industry, Shirabji Godrej Green Business Center in Hyderabad. And currently, I'm working as an environmental engineer, focusing more into product level certifications. This process is called as eco-labeling and life cycle impact assessments for buildings and products. So let us get into today's topic of discussion. And before starting the session, I just want to ask each one of you. It's been almost 7 to 10 years. So my batch is almost exactly 2016 to 2020. So it's been almost 6 years since I completed my bachelor's. Can any one of you give your inputs or comments on how the field has evolved over this last 10 years of period? You can switch on, you can unmute your mic and explain your thought process or view. Even you can put it in the chat box. So to mention how the field was 10 years ago and how it is now and what is expected in the next 5 to 6 years is the intro slide of this presentation itself clearly mention you what has happened, what is happening and what is going to happen. Initially, when we were in the college or when we were working as an intern in a company, especially in civil engineering, construction-based firm or infrastructure-based firm, everything was manual. Even though we say drawings are through CAD or drawings, every communication, every execution was through manual operations. And slowly, once automation came into picture, especially the BIM and the data came into the existence from 2019, 2020. So to give you a perspective on what is CAD, what is BIM, CAD is a computer-aided drawing where the building plans, the building designs are drawn in a software. There are multiple CAD-based software. And now it is into BIM plus data. So BIM is building information modeling. So let's say if you are constructing a new building, all your project schedule, all your labor schedules, and even the timeline, the material requirement, the cost involved, every 5 to 6 amount of set of data is collaborated into one and directly put it into one system. This system is called as building information modeling, and it is purely based on data. Now, almost all the buildings, all the infrastructure projects which you are seeing in and around you, especially in Chennai, the Chennai Metro Rail, without BIM, it cannot be happening now. When the project was initiated, that is a detailed project report was given to the government. It was officially decided that all the data related to the project would be digitalized and put into one system. That's the reason you could observe that the projects are not getting delayed today. Previously, when we say infrastructure project, it would take years and years of time, somewhere around 5 to 10 years of time. But now everything is happening in just a second or just a day. Especially the Chennai Metro Rail construction, the lifting of the girders, the gantry girders, everything happens in one night only. They lay the structures within 3 to 4 hours during the night time. That is the speed this beam can offer. And going ahead, what is the next thing? The next thing is, till now it was only based on performance, money, and everything. Now sustainability is coming into picture. To scale this sustainability, only human minds cannot support this transition. It is the help of the AI, and there are multiple sort of ecosystem. Okay, so let me get into the presentation now. If there are any questions or clarifications, please stop me in the middle. I will be happy to answer your things. Since you are a student and parent fraternity, I just want to explain you what are the various field available in civil engineering, and in the coming days how this field is going to get evolved. Till now, the first and foremost important department in civil engineering is structural. Whoever completes a bachelor's, everyone try to do a master's in structural engineering in the later stages. This is a bread and butter for every civil engineering students and every civil engineering fraternity. Slowly, other departments got into picture: geotechnical, transport, water resource, remote sensing, all of these things. So structural is utilizing the design concepts to design a building, calculating their concrete requirement, what is the grade of the concrete, and what kind of reinforcement. When I say reinforcement, what kind of TMT or steel reinforcement is required. Geotechnical is specifically related to substructure, that is foundation, how this foundation is getting designed, how to build a foundation in a ocean environment or a waterborne environment, everything. And major problem which you are facing today in every city is the transportation. How the transport can be efficiently designed. All of these things comes under transport. And the most important thing is water resource. All your dams, irrigation channels, resource consumptions, all this comes under water resource engineering, hydraulics. So all 4 to 5 departments put together work hand in hand in different type of project based on a application and the use. This is how the entire ecosystem was till now for the past 6 to 10 years. Now it is moving into a different area. It is called as net zero sustainability, all of these things. So sustainability, as a parent or as a student or even as people who are working in civil engineering fraternity, when we ask what is sustainability, the first and foremost answer which we receive is utilizing the resources in a proper way so that it is available to the future environment also. But going ahead, will that only work? Yes, until unless resources is there, until unless if we use it properly, then there will not be any problem. However, there are some limit for certain amount of resources, especially in civil engineering field. You might have seen the transition from the river sand to M sand. When we say river sand, previously people prefer to go with river sand only because of its strength requirement. But once the river sand price increases due to shortages, the ground degradation which is happening due to sand extraction from rivers, all of those things were having some negative environmental impact. So people started to shift to move towards M sand. So what is M sand? That is the gravel is crushed to powder form. It's simply instead of using a direct sand, a gravel or a rock is directly crushed into um, powder form. It almost mimics the sand properties and everything. Till now, all was good and all was fine. But now there is a shortage for M sand also, especially in certain regions like Kerala, West Bengal, everywhere. The resources used to go from one state to other because of resource shortage. So day by day, the resources are getting reduced and it is going into an extinction mode. So that is where the concept of sustainability and net zero comes into picture. How to drastically, till now it was only reduce by a little amount of percentage, do this, do that. But nowadays, people are, and the industries, the developers are looking to reduce it in a drastic way. Say, let's say it can be how to completely eliminate the sand usage and design the concrete mix, how to completely eliminate the usage of water itself. There are some concrete mix without water using some additives which can give you the water properties also. And there are some concrete mixes where industrial waste like steel slag, already steel slag is used, but apart from it, steel slag is used as a coarse aggregate also in certain places. All of these things comes into picture now. So it is coming into the concept of circular economy, resource efficiency, put together is sustainability. Then what is the net zero? Net zero is theoretically how the environmental impact can be made as zero and practically how close it can be brought to zero. When I say zero, every product or every building has a CO2 impact. You might have seen that this vehicle is emitting this much of CO2. Till now, people were in the impression that only vehicles emit CO2. Yes, but apart from it, every product also has a carbon to it. This carbon is called as embodied carbon. When I say embodied carbon, what is it? Due to utilization of raw materials, the extraction, the manufacturing, the processing, what is the CO2 emitted during the entire life cycle? This process is called as life cycle assessment of a product. A similar thing is also done for a building. When I say building, uh, when I say building, people have started to mention what is the amount of material which you are using, whether the amount of material directly impacts the CO2. All of these things are covered as part of the net zero. So this is the entire flow from the starting stage of CAD, BIM, and how it is now evolved into net zero, sustainability, and everything, and what is expected in the future. And when we say net zero and sustainability, the amount of work involved is huge. It's huge. Only humans cannot do it. We need support of the technology. So till now, civil engineering was limited to human beings, small systems. But now in the coming days, it's going to be a integration of AI also. One important thing which you might have observed is, especially in the field of civil engineering, the footfall of students joining the BTech courses in civil engineering has reduced drastically from 2017 or 2018 itself, even when we were there. Now the entire field is facing a shortage. Let me give you a practical example. People are finding it difficult to find in civil engineering background people who have worked in site or even in a large infrastructure projects, at least with 2 to 3 years of experience. It is very difficult to find. This is this level of civil engineering background students and people joining in the sector. And this you might be clearly knowing that it is due to the yes, salary is one of the major thing. Yes, IT gives you a more salary, but in respect to civil engineering, it is the longevity and the stability which it offers. And once you get into this field, it is going to be a long term. Don't think for a short term. It will take some time, some 5 to 6 years. And I say, but it's almost 10 years for me. My experience just 3 years. Out of that, almost 7 years is only into my bachelor's and master's and internships, previous projects and everything. So it will take some time to grow in civil engineering. And to grow in civil engineering, one most important thing which you as a fresh students which you want to adapt is the tools of AI. The tools are changing day by day and it's not going to disappear. And because of shortage of civil engineers in the field also, the role of AI is going to be more important. I will just give you a use case where AI is being used. Previously, the project monitoring in the site used to be done in the site itself every day in the morning session or in the evening session, opening or closing session. So a project manager would be there in the site, a site engineer would be there. They'll discuss what are the previous day's activities, what is the full uh, data monitoring that needs to be done. When I say data monitoring, how much amount of work is done, what is the material which is available in the stock, and what are the labor availability and who's there in the site today, who's not there in the site today. Everything manual records only it was happening. Now everything has been converted into AI integrated CCTV cameras. All the activities are being monitored by the camera itself. The CCTV camera is fed with AI models which can monitor all of those parameters and it can indirectly extract the data. Previously, people used to do it in Excel and feed the data, but now it is not happening. The camera itself is recording the data, monitoring the people, their amount of work, their kind of work. If something goes wrong in the site also, it is directly integrated to the central command. This is a use case for AI in site. Likewise, there are many AI use case in civil engineering, field to field. So these things I've explained to you. I'll just move into um, the use case which I explained with the first scenario itself. And second use case is the quantity and estimation, especially when people are estimating the materials. There would be multiple scenario development. People would be doing Excel sheets, manual Excel sheets. Now AI has been integrated to develop this multiple scenarios. How a concrete mix. Previously, all the concrete mix, especially our professors might be explaining you how a concrete mix is designed and how much time will it take. What is the trial mix? What is the test mix? What is the IS standards behind it? Everything. But it is a huge time consuming and cost involvement also. I'll just give you an example. During our project days, especially in final year, the concrete lab would be full, completely full, because everyone would be doing a project, some project related to concrete and everything. Curing would be happening, mixing would be happening, and the curing tank, it would be completely full. So it is a huge, what you can say, area intensive, space intensive, work intensive. But nowadays, what is happening is how this concrete mixes can be designed even without a human interventions. AI is fed up with the defined set of models as per IS codes or even American standard codes. Based on it, the concrete mix is designed. When I say concrete mix, how much cement needs to be added, how much water needs to be added, how much aggregate needs to be added, all of those things needs to be defined properly in the initial stage itself so that your structure would remain in a safe condition. Now almost 5,000 scenario cases or 6,000 scenario cases is being run by the AI model. Previously, it was not happening. Now it is happening. And we would get the very good amount of optimized mix and even some of the parameters. Let's say your outside temperature is this much, how much water or how much ice I need to add to the concrete mix. All of these things are defined and designed by the AI itself. This is one of the use case for concrete mix design along with AI. And third is cost schedule. Yes, same concept applied to quantity procurement or even mix design, concrete mix design. It is also done to cost prediction and everything. And safety or defect detection. This directly relates with the first case which I've explained, especially in the site. The camera is being used to monitor all of these activities and automatically detects and informs the people. Now, certain what you can say, certain site in the country, even in India, automatic solution retrieval systems are also there as part of this system. So that is the level of advancement which has happened in this field. And one more thing is when we say building, yes, building materials, everything is there. But what about the energy? Till now, energy people might be using it. They would not switch off the fans or light. Yes, building automatic systems would be there, control systems would be there. But the optimization has been done manually with human intervention. When I say optimization, I need to reduce this much amount of light usage so that a human being would define the hours of duration for the operation of the light or the fan or the chillers or the HVAC systems. But nowadays, there are some AI integrated monitoring and building energy management systems where based on your usage pattern. Let's say take an example of college. The college would be operating only in the period of the peak period would be from June to September or for the first semester, maximum October and November, December exam period, semester holidays would be happening. So the usage would be very less. So based on your usage pattern, the building management system will define your operational parameters. When I say operational parameters, how much time this light or fan should run, what is the diesel that I need to purchase for the DG set during my material procurement as a backup, what amount or what capacity of solar power is required. If rain is happening, what amount of solar offset is required. All of these things would be directly decided by the AI itself. This is one of the use case. And the next use case is carbon optimization. This is where I am working as of now. So when we say carbon optimization, as I previously explained, every material has some embodied carbon to it. So when we say every material, let's take a cement, OPC cement, the usual cement which you buy for your home construction and everything. Can you can someone comment what would be the CO2 number? I understand it would be a new concept for you, but you can try Google it out, put it in the chat box, or even unmute your mic and can inform us. So for 1 kg of cement, what is the CO2 impact? What would be the CO2 impact? Can someone comment on this one? Even you can put it in the chat box. I'm just looking in my chat box now. Just to guess, you can do some guesses. Okay, so I'll just give you the exact number. A 1 kg of OPC cement will emit 1 kg CO2 equivalent. So what is 1 kg CO2 equivalent and how it is related? To give you a scale or a number, the earth is surrounded with CO2 molecules and the concentration is 450 ppm. Okay, so when I say 450 ppm, it is some technically speaking, in terms of weight, it would be close to in some gigatons, milli in gigatons. Okay, and can you at least guess what would be the CO2 available in the atmosphere? This you might have studied from your school stages also. School level EVS, all of those things would be explaining these numbers. How much of CO2 is emitted and available in the atmosphere? Can someone guess? Sure. Okay, so let me give you the answer. It is close to 3,500 gigatons. So you understand the scale. When I say gigaton, it's metric ton into 10 power 6. So metric ton is 1000 kg. Then imagine what would be the scale of CO2 available in the atmosphere. So the example which I was explaining is with the cement. So 1 kg of CO2 is emitted due to materials, manufacturing and production of the cement process itself. Likewise, every material have some impact as a product and as a building itself. Okay. So how it is going to be related to sustainable and AI, and what is the role of AI into it? This is where I am mostly going to cover into this picture, because since I'm working in this field for almost 3 to 4 years, I thought let me focus on only this use case, that is AI and sustainability for buildings. Almost 10 years back, it was only green building concept, low energy, reuse of water, waste utilization, everything, indoor air quality. And now it has moved into life cycle thinking. So from a qualitative impact on how the building is green, it has moved to how much impact. So everyone has started to ask the in terms of number terms. Let's say if your building is constructed or a project is constructed, how much CO2 is emitted during the project construction. So all this number is yet to be quantified. When I say yet to be quantified, it is just a beginning phase. Reduction is the next phase, but first calculation itself is one of the most important phase. When I say calculation, it is called as baseline study or a benchmark study. How much impact? To give you a perspective on the amount of work that needs to be done in calculating this number is to calculate a CO2 footprint of a concrete product, it would take at least 3 to 4 months manually. Manually, I am saying. Even when I say manually, some software integration is there. However, you might know how much amount of building materials are available in the country now, and how many companies are there. Almost the building material the building material company size itself is close to 2.5 lakh to 3 lakh crore. I leave the construction part. Only the material part is itself is 2.5 to 3 lakh crores. Out of that, almost some 15,000 companies. So 1,000 to 1,500 are top level companies who are good in business, good in the product development. Some 7,000 to 10,000 MSME companies are there. So for all of the products getting manufactured from this companies or industries, we need to calculate these numbers. Are there time available and resource available, people available to do all of this numbers as of now? Technically speaking and theoretically speaking, there is no people available as of now. So the only option is to utilize technology in the form of AI to calculate this number and move towards net zero carbon. So when I say net zero carbon, because our country has, you might have seen our Prime Minister, Mr. Modi has mentioned that we would be going with Panjamrit. So when I say Panjamrit, what is it? It's low carbon, low energy, low water, low utilization of land and resources. So carbon has a role into it. Every year India does their commitment to UNEP that we would be reducing this much amount of CO2. So when a government does it, automatically every company needs to reduce it. That is the reason why people are calculating these numbers and trying to reduce it. And to calculate this, AI is going to have a huge role into it. Okay. As in, these are some of the points which I said. Where the carbon is going to come from is from especially from the materials, the energy utilized, the transport, the waste generation, everything. So it is beyond the one boundary. It is interconnected to multiple setup. Starts from material mining, extraction, what is the impact during manufacturing process, what is the impact during transportation, what is the impact due to packaging. Use phase also has some impact. Certain materials, especially cement, has more CO2 released into the atmosphere during the use phase. Okay, so once you get into the college, you will be studying the cement, cementitious property, the hydration of cement, all of this thing, and how CO2 is emitted into this atmosphere. That is, we generally calculate this amount of CO2 only in embodied carbon. Okay, so to do all of this environmental impact calculation, AI is going to play a huge role. Okay, I'm just skipping this thing because it's too technical, but you can, to get the understanding what is LCA, you can use this slides. So this is the major area which I want to focus on. And yes, as I was previously explaining, how AI is being used is, it is not from the product itself. It is used in a combination of BIM, the calculating the footprint of the product and calculating the footprint of the building itself. So the flow is, let's say you are building a project, you are going to design a project and going to give a detailed report to your client. As a detailed project report, you would be including what is the cost, what is the amount of material requirement, what is the area, everything would be there. And in the form of digital, when I say digital, 3D images, all of these things would be there. From this 3D images, how can we extract the environmental impact? So in a manual calculation, how we do it is the entire bill of materials. So in civil engineering, we use this term called bill of materials. So to term the quantity of material, we term it as bill of materials. Generally, we do it manually. Till now, for ALC calculation, we do it manually from the drawings or BIM models. But now, there are some AI engines which can automatically extract these quantities from the drawing itself. You need not to feed in any things, just only the drawing and the exact drawings and site conditions. If you do it, the quantities would be first extracted. And the second component is the emission factors. That is, as I previously explained, every product has an impact to it. When I say emission factors, one example is the cement. So 1 kg of cement is having 1 kg COD equivalent. Likewise, every material has this thing. So the quantity and the emission factor would be multiplied, and then the total CO2 emission of a building would be arrived upon. So this is how the calculation was happening till now in a manual stage. But now everything is automated. So total kg CO2 equivalent of an entire building, because of building construction, building material, its energy usage and everything, the CO2 emission is calculated on a per square meter basis. So the time difference is, when we do it in a manual basis, it will take at least 1 week to 1.5 weeks of time just to do a building LCA. Product LCA is a more complex thing. I'll come for the product LCA in the next stages. So it is almost 1 week of time. And now integration of AI allows it to do it within a fraction of seconds. 10 to, if all the quantities are properly mapped and everything is there, can finish it in half an hour. That is the level of speed and the accuracy, and AI can also give you a report. Previously, all the report would be manually prepared by humans. Now AI is capable of preparing the reports in the format which you define. So starting from design, calculation, report, everything is mapped with AI. You might be asking me one important question. If everything is being done by AI, then what is the use of a human being there? See, till now, AI is just a calculation thing. It can also make mistakes. So humans have a role of doing the verification, and for verification, you should be very thorough in your basics. So unless your basics are not strong, you cannot say whether the content generated by AI is right or wrong. That is where the role of AI, humans are going to come. Okay, so this is the major thing. So I just want to inform the students and parents also, please don't consider it as a hindrance, that is a limitation. Consider it as an opportunity. Unless you embrace it, things will be little difficult in the coming days. Okay. One more area is benchmarking. As I explained, there are multiple levels of products, multiple building typologies, and this is the area which I completely work into benchmarking and baselining. To give you what is benchmarking and baselining is, you might be aware about the ratio, especially in food. To prepare a biryani, this much of ratio of materials, chicken is required, rice is required, water is required. It is predefined from experience. However, when a ratio or a quantity is not predefined, the activity which is done to understand what is the right amount, what is the right way to do it, it is called as benchmarking and baselining studies. So, if, as I mentioned, cement would be having 1 kg. To arrive at this number, it took almost 15 to 16 years manually, a proper benchmark. Likewise, we need to do for almost all the companies, 15,000 companies which I mentioned, all the product categories starting from cement, steel, glass, paint, plaster, your interior furnitures, your aggregates, your admixtures, even for water, DM water, RO water, everything, the impact needs to be calculated. And there should be a proper limit that needs to be defined. Till now, even not in India, even at a global stage, the levels are not properly defined. So to do this benchmarking and baselining activity, only humans are not going to be sufficient. AI role is going to play a huge role because huge amount of data is involved into it, not one amount of data. The boxes which you see is all as a data parameter, climate zone, building type, area, occupancy, operating hours. Everything is a little technical, but just get a brief understanding. These are some of the parameters which is used to arrive at the baseline numbers. Okay. Likewise, all the parameters needs to be calculated again and again for all the product categories. So you please understand how much time. When I say building, it is just 1 week to 2 weeks. But if it's for a product, it's almost 4 to 6 months. So this much amount of work is required. And going ahead, AI is the only solution for this benchmarking and baselining studies. And my work is majorly involved into this kind of study only. We have done some benchmarking for paints, buildings, especially buildings and office buildings in Gujarat, Tamil Nadu, Chennai, and we have given these numbers to government also. So when we give these official numbers, government will incorporate these numbers into their building plan development things, especially CMDA or CMRL projects or even infrastructure projects. So they put it in what we can say project requirements that your construction should achieve this number to pass the criteria. All of these things will be done as part of EAI and sustainability for benchmarking and baselining. So this is some of the same things which I mentioned, and it is used also for scenario analysis for various applications. And let me not get into detail because it will, since we are a beginning stage, let me limit it to basic set of examples only. So to conclude this, almost we are at the final session. That is the final slides. To conclude this, I just want to inform you one thing. Till now, it was only the manual introduction. And to convert it to a sustainable AI and a civil engineering background people, you need not to be a AI expert. Definitely, you need to be a civil engineering expert to say whether the things which is done by AI is right or wrong. But you need not to be a AI expert completely. Whether I need to learn codes, whether I need to learn Python, Java, or all this programming language. Technically, no. Even the code can be written by AI now. So you need to know what I should ask the AI, what I need from AI, what is the use case from AI, how to connect with my day-to-day workflow. So this is one of the major skills that you need to develop as a student in the coming days, especially in civil engineering field. Okay, people who do this will definitely sustain in this field for a long period of time. And please don't have this fear that AI will replace our job. No, definitely it will not do that. Still, the decision making is with the human beings. So please be aware about it. Use this as a toolkit for your career development and continuous incremental activities. So thank you, everyone. I'm just ending this session as of now. I'm opening the floor to your questions, queries, clarifications, and everything. Please feel free to ask your questions. Okay.
Dear participant, please ask questions in chat box. Any queries? Yes, students. Thank you.
So thank you everyone, and thank you once again. I thank SAC College for giving this opportunity for me to present on this requirement to the fresh set of students and the parents, especially who are entering into the college now. So thank you everyone. And if you want to connect with me or have some queries or clarification which you want to discuss personally also, I'm just dropping my LinkedIn ID in the chat box. Please have a note of it. You can drop me a message there. Okay, so I'm
Thank
also
you.
giving you one more advice. Please be, instead of using social media like Instagram and everything, focus more on LinkedIn. LinkedIn is where most of your activities are going to come, and even the job market, it's not going to be a placement kind of thing. In the coming days, it's going to be peer-to-peer network based things only. So this is how it is going to be. It would be very useful for your career also. Okay, fine. Just a moment. I'm just putting
Thank,
the LinkedIn profile. Thank you, everyone.
thank you. Thank you so much. And I would like to thank our Chief Resource Person, Mr. Alagappan, for having accepted our request this day. Share this the knowledge with us, sir. Thank you. I would finally thanks our management, principal, and head of the department for us with indeed of enrich our knowledge. Also thank the students and faculties, my colleagues. I hope thanks many more such event, the grand successful of event. Thanks once again. I like thanks. Thank you, sir. Thank you.
Thank you. Thank you. Bye.